Hello, ladies and gentlemen, and today what we're going to look at is a little bit about variation of insulation, and basically this is going to come from pages 105 to 109 in the review book. So when we consider variation of insulation, insulation varies from place to place on Earth's surface. It varies over the course of a year. It also varies over the course of a day, and it varies based on seasons as well. So there's another number of factors that affect insulation. Earth's shape is one, right? Earth is spherical. So because it is round in shape, not every location receives the same amount of insulation. Also, the thickness of Earth's atmosphere plays into a role, right? Because some places Earth's atmosphere is going to be a little thicker, more cloud cover, more gases, and that's going to affect the amount of radiation that's received. Also, if we consider latitude, the closer you are to the poles, the less sunlight you're going to receive. The closer you are to the equator, the more sunlight you're going to receive. The season is going to play a role, of course, as well, depending on if the Earth has the northern hemisphere tilted towards the sun, or if we're in winter and the northern hemisphere is tilted away from the sun, right? So that's going to affect the amount of insulation we receive. And also the time of day, right? We get the most insulation at noon when the sun is highest in the sky, hence the old phrase, high noon. So this graphic shows us a little bit about how the fact that these higher latitudes that are up in this region do not receive as much insulation as they do down here at lower latitudes. And again, that reason is because if you notice, the sun's rays at the higher latitudes up here, well, these rays here are spread out, right? So they're not as concentrated as they are near the equator. And that's the underlying factor in this, is that the rays are spread out. And again, you can see how Earth's spherical shape is really the reason for that. Okay? So what is perpendicular insulation? When we say perpendicular, we mean the angle at which the rays are striking Earth's surface. So in this graphic, right there is nearly perpendicular, whereas closer to the poles, we are at a very low angle of insulation, right? So when we refer to how perpendicular are the rays to Earth's surface, we're also referring to the angle at which they strike Earth's surface. So where do you think a shadow would be the shortest? Would a shadow be shorter at A, or would a shadow be shorter up here at B? Well, if you picked A, you are correct, because the sun's rays would be directly overhead. So when you're standing there you are standing, right? And the sun is directly overhead, well, the shadow is going to be right under you. Whereas if we were in a location where the sun is a little bit lower in the sky, like northern latitudes, right? Then the sun is over here at B, for example, and then our shadow is going to be very long. So shadows are the longest when we're up near the poles. Okay, this animation goes over the rates of sunlight and how they're received, and you can play this on your own after you end this screencast. So how insulation varies throughout the day, right? So the longest shadows, of course, are at sunrise and sunset, and the shortest shadows are when we're at noontime, right? So we can see in this bottom graphic here, in the morning, the sun is low in the sky, and it's rising in the east, which means, which way is that shadow pointing? That must be west, right? Because the sun is rising over here in the east, okay? By noontime, the shadow is very short and it's right behind it. And in the afternoon, then this shadow is the opposite. It must point east, and over here must be our sun in the west. Okay, so if we look at the graph that shows us the changes throughout the day, we can see here how at noon, hence the term high noon, that is when the sun is highest in the sky, right? You can see from A all the way to E how that shadow changes throughout the day. If we look at the times of yearly maximum and minimum temperatures, this is a very interesting graph. This is actually goes along with lab 6-3 that we did or will do on heat budget, right? So what we did is we're looking at when the minimum temperature is and when the minimum angle of insolation is. So if I look at the lowest angle of insolation, that's my lowest angle. But notice the minimum temperature is about a month and a half later, there near the end of January. And I wonder why that is. Well, it goes back to the idea that our Earth is mostly water, and so it takes a long time for that water to cool off when we go into the winter months. And so we're going to have that little bit of lag time, right? Where we've constantly been losing energy, right? Losing energy here in November and December, but we're going to have a minimum temperature that's a little later on because of the fact that it's going to take the water has a high specific heat, and it's going to take a long time to cool off. Likewise, when we go to June, well, here's our maximum, right? But June 21st isn't the highest temperatures of the year. The highest temperatures of the year are over here in July, end of July or early August. And that, again, is because it takes a long time for that water to heat up. So there are variations in insolation throughout the year, and the temperatures, high and lows, do not line up with the times of maximum and minimum insolation, right? If we look at it on a daily scale, right, this graph is very loaded. We can see that right here is our daytime angle of insolation, right, from sunrise to sunset. And just like the year, we're not going to have our highest temperature of the day at high noon, right? Here is our high noon right down the middle. See that right there? That's our high noon, and our maximum angle of insolation is right there. However, the hottest time of the day is here, right, at the 3:30 hour. And again, that is because it's going to take time for Earth to heat up during the day and time for it to cool off. So our coldest temperatures are actually just after sunrise. That's when it's going to be the coldest. Sadly, that's when most of you guys are waiting for the bus, just after sunrise. And our hottest temperature of the day is actually going to be just after school lets out, sometime around 3 o'clock. So again, same idea. In the seasons, there's lag time. In the course of the year, there is a lag time. And also in the course of a day, there is a lag time. And in this case, when I say lag time, I mean that the maximum insolation does not coincide with maximum temperatures, right? Likewise, minimum insolation does not coincide with minimum temperatures. There's always a little bit of they're always running a little behind each other. Okay, so let's go ahead and answer some checkpoint questions on the slideshow, and you can go back and view that animation that I skipped earlier.